Welcome everyone. This is the task video for energy and chemical change. We will do some practice questions on the different aspects that we covered in this series. Have your pen and paper ready to answer the questions. Remember to pause the video after each question so that you can work out the answer before going on to the next question. Let's begin. Define the terms exothermic and endothermic reaction. Classify this reaction as either exothermic or endothermic. When two chemicals mix, their temperature rises. Classify the reaction as either exothermic or endothermic. A solid burns brightly and releases heat, light, and sound. Classify the reaction as either exothermic or endothermic. When two chemicals are mixed, their temperature drops. Classify the reaction as either exothermic or endothermic. Two chemicals will react only if you heat them continuously. Classify the reaction as either exothermic or endothermic. Plants take in light energy for photosynthesis. Classify the reaction as either exothermic or endothermic. Water plus energy reacts to form hydrogen and oxygen. Classify the reaction as either exothermic or endothermic. Solid magnesium plus chlorine gas react to form solid magnesium chloride and heat energy. Classify the reaction as either exothermic or endothermic. Iron and sulfur react to form iron sulfide. Delta H is negative. Classify the reaction as either exothermic or endothermic. Potassium nitrate reacts to form potassium nitrate and oxygen, and delta H is positive. And now for the last one. Classify the reaction as either exothermic or endothermic. A plus B react to form AB, and delta H is negative 129 kilojoules per mole. Now we have a question on how to calculate the heat of reaction by making use of the bond energies. Please take note that a table of bond energy values is given to you in the series guide. This equation shows the reaction between ethene and oxygen. C2H4 reacts with 3 moles of O2 to form 2 moles of CO2 and 2 moles of H2O. The structural formulae shows the bonds in each molecule involved. Calculate the total energy changes involved in breaking and in forming all of these bonds. Make use of the values given in the table in the series guide. Identify the reaction as endothermic or exothermic. Remember to look in the series guide for the bond energies of the bonds. Use bond energies to calculate the enthalpy change in this reaction. 1 mole of hydrogen reacts with 1 mole of fluorine to form 2 moles of hydrogen fluoride. Use bond energies to calculate the enthalpy change in this reaction. 2 moles of sulfur dioxide react with 1 mole of oxygen to form 2 moles of sulfur trioxide. Use bond energies to calculate the enthalpy change in this reaction. 1 mole of propene reacts with 1 mole of bromine to form 1 mole of 1,2 dipromopropane. The next type of question involves drawing graphs of the reactions. Remember to draw the potential energy on the y-axis and the reaction coordinate on the x-axis. The complete combustion of acetic acid with the formula CH3COOH in oxygen gas to form water and carbon dioxide at constant pressure releases 871,7 kilojoules of heat per mole of acetic acid. Write a balanced chemical equation for this reaction. How much heat in kilojoules would be released if you burned 2 moles of acetic acid? Draw a potential energy diagram for the reaction. Draw a labeled potential energy diagram for a reaction in which the total energy of the reactants is 50 kilojoule per mole. The total energy of the products is 120 kilojoules per mole, and the activation energy for the forward reaction is 120 kilojoules per mole. Is this reaction exothermic or endothermic? In question 9, we look at a hypothetical reaction. Consider the reaction A plus 2B reacts to form C. In this reaction, the total energy of the reactants is 80 kilojoules per mole. The total energy of the products is negative 90 kilojoules per mole, and the activation energy for the forward reaction is 120 kilojoules per mole. Draw a labeled potential energy diagram for this reaction. Use the diagram to state whether the reaction is endothermic or exothermic. Calculate the energy difference between the reactants and the products. Deduce the sign of the enthalpy change. Identify with a reason which is more stable, the reactants or products. In our last two questions, we will interpret given energy diagrams. You can also look at these diagrams in your series guide. Which of the letters A to F in the diagram represents the potential energy of the products? Which letter indicates the potential energy of the activated complex? Which letter indicates the potential energy of the reactants? Which letter indicates the activation energy? Which letter indicates the heat of reaction? Is the reaction exothermic or endothermic? What can be done to lower the activation energy of the reaction? And now for the last question. Use the diagram to answer the following questions. Does the graph represent an endothermic or exothermic reaction? Determine the heat of reaction delta H for this reaction. Determine the activation energy E subscript A for the reaction. What is the energy of the activated complex for this reaction? Grade 11s, these are just a few examples of possible questions on the topic of energy and chemical change. It is extremely important that you practice a lot more. This topic is again visited in grade 12 in rates of reactions and will also be included in your final grade 12 paper. Keep well. Goodbye.